Let's see the example problem on crashing of a project. Given below is the table showing durations and cost of various activities of a project. The overhead cost of the project is 6,000 rupees per day. Determine the optimum duration of the project and the corresponding cost. Let's see the solution. First step is find the normal critical path and identify the critical activities. So first draw the network diagram. So first I have to start with the activity 1 to 2. So draw the activity 1 to 2. Next we have to draw the activities 2 to 3, 2 to 4 and 2 to 5. These three activities will be start at the event 2. So I have to draw the activity 2 to 3, 2 to 4 and 2 to 5. So next we have to draw the 4 to 5 and 3 to 5. So if you draw the activities 4 to 5 and 3 to 5, so it is very difficult to draw like this. Then I have to modify the activities 2 to 3, 2 to 4 and 2 to 5 like this. So next we have to draw the activity 4 to 5. So next activity 3 to 5. Next activity 5 to 6. So next we have to represent the normal time as well as the crash time for the each activity. For activity 1 to 2, normal time is the 3 and crash time is the 2, which is represented in the brackets. Similarly, we have to represent the normal time and crash time for the all the activities. For activity 2 to 3, so normal time is the 4 and crash time is the 2. And next activity 2 to 4, 2 to 4 normal time is the 3 and crash time is the 1. For activity 2 to 5, normal time is the 4 and crash time is the 3. And next for the 3 to 5, normal time is the 2 and crash time is the 1. And next for the activity, so 4 to 5, for activity 4 to 5, so normal time is the 5 and crash time is the 2. And last activity 5 to 6, so normal time as well as the crash time both are the 5. So this is the network diagram. So next we have to identify the critical path. So first we have to identify the various activities of the possibilities in the given network diagram. First possibility of the path is 1 to 2, 2 to 4, 4 to 5 and 5 to 6. Its duration is, consider only the normal time, that is the 3 plus 6, 6 plus 5, 11. So 11 plus 5, 16. So next another possibility of the path is 1 to 2, 2 to 5 and the 5 to 6. And duration is in the path 1 to 5, 6, 3 plus 4 plus 5, which is the 12. And next another possibility of the path is there, that is the 1 to 2, 2 to 3, 3 to 5 and 5 to 6. So in this path, duration is 3 plus 4, 7, 7 plus 2, 9, 9 plus 5, 14. So there is the three possibility of the path is available for the this network diagram, and critical path is the maximum duration. So here maximum duration is possible with the path 1 to 2, 2 to 4, 4 to 5 and 5 to 6. Duration is 16 days. So path 1 to 2, 2 to 4, 4 to 5 and 5 to 6 is the critical path and duration is the 16 days. So next we have to calculate the cost of the project. Cost of the project equal to the normal cost of the all the activities plus indirect cost. Here normal cost of the all the activities are the 5,000 plus 6,000 plus 9,000 plus 5,000 plus 7,000 plus 8,000 plus 20, which is equal to the 60,000. And indirect cost is the project duration plus overhead cost. Here project duration is the 16 days and overhead cost per day is the 6,000. Then indirect cost will become the 16 days into 6,000 per day. So total cost of the project is the 60,000 plus 16 into 6,000, which is equal to the 1,56,000. So next step is the calculate the cost slope for different activities and rank it. So for this one, I have to determine the cost slope. Cost slope is defined as the crash cost minus normal cost divided by normal time minus crash time. So how to determine the cost slope for the all the given activities. So for the activity 1 to 2, cost slope equal to the crash cost minus normal cost. So which is equal to the 7,000 minus 5,000 divided by 3 minus 2, which is equal to the 2,000 divided by 1, which is equal to the 2,000. So next for the activity 2 to 3, 10,000 minus 4,000, sorry 10,000 minus 6,000, which is equal to the 4,000 divided by 4 minus 2, which is equal to the 4,000 divided by 2, which is 2,000. So next for the 2 to 4, 17,000 minus 9,000, it is the 8,000 divided by 3 minus 1, 2, which is equal to the 8 by 2 equal to the 4,000. Next for the 2 to 5, 9 minus 5, so 4,000 divided by 4 minus 3, 1, so 4,000. Next for the activity 4 to 5, 16 minus 7, which is equal to the 9,000 divided by 5 minus 2, which is equal to the 3. So 9,000 divided by 3, which is equal to the 3,000. Next for the 3 to 5, 9,500 minus 8,000, 1,500 divided by 2 minus 1, which is equal to the 1,500. Next for the 5 to 6, so 2,000 minus 2,000, 0 divided by 5 minus 5, 0. So we are not considering the cost slope for the activity 5 to 6. Next we have to give the rank based on the cost slope value. So we have to give the first rank for the minimum value. So next rank for the next minimum value. So here a minimum value is the 1,500 for the activity 3 to 5. So I have to give the rank 1 for the cost slope value of activity 3 to 5. Next one is the 2,000 is the minimum values for the activity 1 to 2 and 2 to 3. So I have to give the rank 2 for the both of the activities. And next is the 3,000 for activity 4 to 5. So I have to give the rank 3 for activity 4 to 5 cost slope. And next to for minimum value is the 2 to 4 and 2 to 5, 4,000. For the both of the activities cost slope, we have to give the 4th rank. And activity 5 to 6 cost slope, we are not considering. So next I have to move to the third step. So I have to go for the crashing. By crashing the activities on critical path, other path also become critical and are called the parallel path. So here there are the three possibility of the paths are there. That is the 1, 2, 4, 5, 6. Its duration is 16. And crashing time will become the 2 plus 1 plus 2 plus 5, 10 days. So maximum possibility of the crashing is 10 days. Similarly, I have to look for the another path 1, 2, 5, 6. So 1, 2, 5, 6 path. Duration is 12 and crashing time will become the 2 plus 3, 5, 5 plus 5, 10. So here also 10. And next another path is the 1, 2, 3, 5, 6. So here duration is the 14 and crashing time is the 2 plus 2, 4, 4 plus 1. So 5 plus 5, which is equal to the 10. So here maximum possibility of the crashing is 10 days. So next we have to start the crashing. Before starting the crashing, draw the tabular column like this. First column is represent the normal duration. And next column is the crashing of the activity. And next column is the crashing cost. Next column indirect cost, and which is equal to the overhead cost into the number of days. And last column is the total cost, which is the normal cost plus indirect cost plus crashing cost. So always have to start with the without any crashing. And normal duration is the duration of the critical path. So duration of the critical path is the 16 days. So normal duration is the 16 days. And there is a no crashing. So no crashing activity, and there is a no crashing cost. And indirect cost will become the overhead cost is the 6,000 and 16 days. So it is the 96,000. And total cost will become the, so normal cost, which is the 60,000 plus indirect cost is the 96,000 plus crashing cost is the 0, which is equal to the, so 60,000 plus 96,000 plus 0, which is equal 1,56,000. So next I have to go for the crashing. So remember, always you have to do the crashing only for critical activities. So here critical path is the 1, 2, 4, 5, 6, and critical activities are the 1 to 2 and 2 to 4 and 4 to 5 and the 5 to 6. So have to do the crashing only these critical activities. Now question will be raised. First, which activity have to go for the crashing? So always have to select the crashing for the critical activities based on its minimum cost slope. So for the activity 1 to 2, its cost slope is the 2000, and next for the 2 to 4, it is the 4000. Next for the 4 to 5, it is the 3000, and activity 5 to 6 we are not considering. So among these 2000, 4000 and 3000, minimum value is the 2000 for the activity 1 to 2. So first you have to crash the activity 1 to 2. It is activity lying on the critical path and with minimum cost slope. So I have to select the activity, so 1 to 2. So here for the activity 1 to 2, normal duration is the 3 days and crashing days is given the 2 days. Okay, first I have to reduce the activity 1 to 2 for the 1 day. Then normal duration will become the 15 days. 1 day we are reducing. Then normal duration is the, so 1 day it is reducing, and crashing the activity is 1 to 2 for the 1 day. And crashing cost. So crashing cost is the cost slope into number of days. So here cost slope is the 2000, and we are reducing the day is the only 1 day. So crashing cost is the 1 into 2000, which is equal to the 2000. Next one is the indirect cost. Indirect cost is the overhead cost into normal duration. Here normal duration is the 15 days only. Then indirect cost will become the 6000 into 15, which is equal to the 90,000. Then total cost is the normal cost is 60,000 plus indirect cost is the 90,000 plus crashing cost is the 2000. Total is the 1,52,000. Okay, so now it is the activity 1 to 2 is lies on the 3 path. So for the path 1, 2, 4, 5, 6 also 1 day it is reducing. Then 16 minus 5, it is the 15 days. Similarly, activity 1 to 2 is the activity for path 1, 2, 5, 6. Here also 1 day reducing. So in the 1, 2, 5, 6 path is reducing to 12 to 11. And similarly 1 to 2 is the activity for the path 1, 2, 3, 5, 6. So in the path 1, 2, 3, 5, 6 also one day it is reducing. So 14 to it will be reduced into the 13. And similarly, so in the path 1 to 2 is, so normal time is the 2 days and also crashing time is the 2 days. So next we have to observe here. For activity 1 to 2, normal time is the 2 days and crashing time also 2 days. So normal time equal to the crash time. So further crashing is cannot apply for the activity 1 to 2. So next further crashing is not possible with the activity 1 to 2. Then I have to look for the another critical activity. So here remaining critical activities are the, so 2 to 4 and the 4 to 5 and the 5 to 6, but 5 to 6 we are not considering for the crashing. So now 2 to 4 and the 4 to 5. For the activity 2 to 4, cost slope is the 4000, and for the activity 4 to 5, cost slope is the, so 3000. So we have to select the critical activity 4 to 5. So crash the activity 4 to 5. It is the activity lying on the critical path and with minimum cost slope. So you have to go for the crashing of activity 4 to 5 for the 1 day. Then normal duration it will be reduced to 15 to 14 days. So crashing the activity is the 4 to 5 for the 1 day. And crash cost will become the previous crashing cost, that is the 2000 plus 1 day. We are going for the crashing of the 1 day. So 1 day into the cost slope of the activity 4 to 5, that is the 3000. So 1 into 3000. Then crashing cost is the 2000 plus 1 into 3000, it is the 3000. So 2 plus 3, which is the 5000. So next is the indirect cost, which is the 6000 overhead cost, and number of days now it will become the 14 days. So 6000 into 14, which is equal to the 84,000. Now total cost will become the normal cost, it is the 60,000 plus indirect cost, which is equal to the 84,000 plus crashing cost, which is equal to the 5,000. Then 60,000 plus 84,000 plus 5,000, which is equal to the 1,49,000. So okay. So now, so duration on the path 1, 2, 4, 5, 6 is 15 to 1 day is reducing, that is the 14 days. So activity 4 to 5 is lying on the only 1, 2, 4, 5, 6 path only. So remaining path it is the not lying. So remaining path, so duration it will be not reduced. Only for 1, 2, 4, 5, 6 path only number of days will be reduced, that is the 15 to 14. Okay. So here for the activity 4 to 5 we are reducing into the 1 day. So that is the normal time is 5 days. So it is reducing into the 4 days. And the crashing time is the 2 days only. So we can be go for the further crashing. So once again I have to go for the further crashing with the same activity 4 to 5. So have to go for the another 1 day. Then normal duration will become the 13 days. And crashing the activity 4 to 5 another day. So second day. And crashing time will become, crashing cost will become the previous cost is the 5,000 plus now another 1 day. So 1 day into the, so cost slope is the 3000. Then 5000 plus 3000, which is equal to the 8000. And indirect cost is the 6000 into 13, which is equal to the 78,000. And total cost will become the 60,000 normal cost plus and 78,000 indirect cost plus and crashing cost is the 8,000, which is equal to the 1,46,000. So now duration in the critical path 1, 2, 4, 5, 6 is reduced into the 13 days. And similarly we have to see for the in the network diagram also. So it is reduced into the, so 3 days as the normal time and 2 days as the, so crashing time. So here observe that after crashing to 13 days, we get the parallel path, namely 1, 2, 4, 5, 6 and 1, 2, 3, 5, 6, which means after the crashing to the 13 days, critical path duration, that is the 1, 2, 4, 5, 6 path duration is the 13 days. Similarly, another path, that is the 1, 2, 3, 5, 6 duration also 13 days. Now 1, 2, 4, 5, 6 is the critical path with 13 days. Similarly, another path 1, 2, 3, 5, 6 is the parallel path with the 13 days. So by crashing the activities on the critical path, other paths also become critical and are called parallel path. In such cases, the project duration can be reduced by crashing activity simultaneously on the parallel critical path. So in this condition, we have to do the crashing on critical activities on the critical path, as well as we have to do the crashing on parallel path also. So here in the critical path is the 1, 2, 4, 5, 6 and critical activities are the 1 to 2, 2 to 4, 4 to 5 and 5 to 6. Among these critical activities, 1 to 2, crashing of 1 to 2 already we are finished, and 5 to 6 is we are not considering for the crashing. So remaining activities are the 2 to 4 and 4 to 5. Similarly, you have to observe the another path, that is the parallel path 1, 2, 3, 5, 6. In this one, crashing activities are the 1 to 2, 2 to 3 and 3 to 5, 5 to 6. In this one, so 1 to 2 crashing is finished and 5 to 6 activity we are not considering for the crashing. So in the parallel path, so remaining activities for the crashing is 2 to 3 and the 3 to 5. So critical path and the parallel path, there is the no common activities for the crashing. So in this condition, as there is no common activity between these two paths, we crash the activity 4 to 5 on the 1, 2, 4, 5, 6 path and 3 to 5 on the path 1, 2, 3, 5, 6 as the activity having the minimum rank. So now among these two paths having there is no common activity, then so based on its cost to slope we have to select the activity for the crashing. So here for the path 1, 2, 4, 5, 6 between the 2 to 4 and 4 to 5, minimum cost to slope is the for the activity 4 to 5, which is having the so 3000. So 4 to 5 and the 2 to 4. Similarly for the another path 1, 2, 3, 5, 6. So activities are the 2 to 3 and so 3 to 5 we have to do for the crashing. So between these two, minimum cost to slope is the 1500 for the activity 3 to 5. So that is the, so as there is no common activity between these two paths, then we have to crash the activity 4 to 5 on the path 1, 2, 4, 5, 6 and activity 3 to 5 on the path 1, 2, 3, 5, 6 as it is the activity having the minimum cost slope. So okay, next we have to go for the crashing of the activity 4 to 5 on the path 1, 2, 4, 5, 6. Similarly, we have to do the crashing of the activity 3 to 5 on the another path 1, 2, 3, 5, 6. Okay, let's have to go for the crashing for the 1 day. Then normal duration will become the 12 days. Crashing the activities here, two activities. One is the 4 to 5 on the path 1, 2, 4, 5, 6. Another activity is the 3 to 5 in the path of the 1, 2, 3, 5, 6. Then crashing cost. So previous cost is the 8000 plus crashing cost of the activity 4 to 5. That is the 1 day into activity 4 to 5, cost slope is the 3000. So 1 into 3000 plus, so crashing time of the activity 3 to 5 is the 1 day and its cost slope is the 1500. So 1 into 1500. Then crashing cost will become the previous crashing cost 8000 plus 1 into 3000 for the activity 4 to 5 plus 1 into 1500 plus for the activity 3 to 5. Then crashing cost will become the 12,500. So and indirect cost will become the 12 days and overhead cost is the 6000. So 12 into 6000 which is the 72,000 and total cost will become the normal cost 60,000 plus and indirect cost 72,000 plus crashing cost 12,500. Then total cost will become the 1,44,500. So now duration on the path 1, 2, 4, 5, 6 is reduced to 13 days to 12 days. Similarly, path 1, 2, 3, 5, 6 duration will become the 13 to 12 days. Same we have to represent on the network diagram also. So for the activity 4 to 5, so it will be reduced to 3 days to 2 days and moreover I have to observe normal time and crashing time both are the equal. Then we can't able to further crashing for the activity 4 to 5 and similarly, so for the activity 3 to 5 also reduced to 2 to 1 day and its crashing time also 1 day. So activity 3 to 5 also we can't able to do for the further crashing. So for the activity 4 to 5, normal time equal to the crash time. Similarly, for activity 3 to 5, normal time equal to the crash time. Then further crashing is can't apply for these two activities. Now path 1, 2, 4, 5, 6 duration is the 12 days. Similarly, another path 1, 2, 3, 5, 6 duration also 12 days. So now these two paths are the parallel path. So in this condition, I have to go for the crashing the activities on these two paths. And one more thing you have to observe. In the path 1, 2, 4, 5, 6, there is only one activity is remaining for the crashing, that is the 2 to 4. Similarly, in the path 1, 2, 3, 5, 6 also there is only one activity is remaining for the crashing, that is the 2 to 3. So as there is no common activity between these two paths, we have to go for the crashing the activity 2 to 4 on the path 1, 2, 4, 5, 6 and 2 to 3 on the path 1, 2, 3, 5, 6 as it is the activity having minimum cost slope. So I have to go for the crashing. So for the 1 day, then normal duration will become the 11 days and crashing the activities are the 2 to 4 in the path of the 1, 2, 4, 5, 6 and crashing the activity 2 to 3 on the path 1, 2, 3, 5, 6. So now crashing cost. Previous crashing cost is the 12,500 plus crashing cost of the activity 2 to 4, that is 1 day into its cost slope is the, so for the 2 to 4 is the 4,000. So 1 into 4,000 plus 1 into 2 to 3. So 2 to 3 cost slope is the, so 2000. So 1 into 2000. Then crashing cost is the 12,500 plus 1 into 4,000 plus 1 into 2000 which is equal to the 18,500. And indirect cost is the 6,000 into 11 days which is equal to the 66,000. Then total cost will become the normal cost 60,000 plus indirect cost 66,000 plus crashing cost 18,500. Total is the 1,44,500. So now, so project duration will become the 11 days in the path of the 1, 2, 4, 5, 6 as well as in the path of the 1, 2, 3, 5, 6. So same thing you have to represent in the network diagram also. So for the activity, so 2 to 3. So 1 day is reduced, then normal time is the 3 and crash time is the 2, and similarly you have to represent in the, so for the activity 2 to 4, so that is the reduced to 3 days to 2 days normal time, and crashing time is the 1 day. So here observe that after crashing to 11 days, we get the parallel path, namely 1, 2, 4, 5, 6, 1, 2, 3, 5, 6 and 1, 2, 5, 6. So after crashing to the 11 days, all the three paths having the same duration, that is the 11 days. So now all these three paths are the parallel path. So in this regard, and moreover there is the no common activity between these three paths, because for the path 1, 2, 4, 5, 6, there is possibility of the crashing is only for 2 to 4. And similarly, in the path of the 1, 2, 5, 6, so 1 to 2 is finished and 5 to 6, we are not going for the crashing. So here only activity 2 to 5 for the crashing. And similarly, in the path of the 1, 2, so 3, 5, 6 also, there is possibility of the crashing is only one, that is the 3 to 5. So here there is the no common activity between these three paths. So in this regard, individually have to do the crashing for these three paths. So as there is no common activity between these three paths, then you have to crash the activity 2 to 4 on the path 1, 2, 4, 5, 6 and activity 2 to 3 on the path 1, 2, 3, 5, 6 and activity 2 to 5 on the path 1, 2, 5, 6 as the activity having the minimum cost slope. So now we have to go for the crashing for the 1 day. The normal duration will become the 10 days, and crashing activities are the 2 to 4 for the path of the 1, 2, 4, 5, 6 and 2 to 3 for the path of the 1, 2, 3, 5, 6 and activity 2 to 5 in the path of the 1, 2, 5, 6. Then crashing cost will become the previous crashing cost is the 18,500, and cost slope for the activity 2 to 4 is the 4,000, then 1 into 4,000. Similarly, cost slope for the activity 2 to 3. So for the 2 to 3, its cost slope is the 2000, then 1 into 2000, and cost slope for the activity 2 to 5. So for the 2 to 5, cost slope is the 4000, then 1 into 4000. Then crashing cost will become the 18,500 plus 1 into 4000 plus 1 into 2000 plus 1 into 4000, it is the 28,500. And indirect cost will become the overhead cost 6,000 into 10 days, it is the 60,000. Then total cost is the, so normal cost is the 60,000 plus indirect cost is the 60,000 plus crashing cost is the 28,500. Then total cost is the 1,48,500. So here observe that project cost is increasing after the 11 days. So for the 11 days of the crashing, so total cost is the 144,500, but for the crashing of the 10 days is the 148,500. Then project cost is increasing after the 11 days. Hence the optimum project duration is 11 days with the total cost of 1,44,500. So this is the solution, and thank you.